Hello dear students, let us solve some model questions issued by CDC 2077. First question, A part. A jumbo jet of mass 4 into 10 to power 5 kg traveling at speed of 5000 meter per second lands on the airport. It takes 2 minutes to come to rest. Calculate the average force applied by the ground on the aeroplane. So, solution to question 1a. Given mass of aeroplane is 4 into 10 to power 5 kg. Initial velocity is 5000 meter per second and final velocity when landing is 0, comes to rest. Time taken is 2 minutes. 2 minutes, which is 2 into 60 means 120 seconds. We have to find the average force applied by the ground on the aeroplane force. Now B is equal to U plus 80 gives 0 is equal to U plus 80. Therefore, A will be equal to minus U upon T minus 5000 upon T is 120, that is minus 500 upon 12 meter per second square. Minus indicates retardation. Therefore, average force will be F is equal to M into A. M is 4 into 10 to power 5 and A is minus 500 upon 12, which gives the average force as minus 1.67 into 10 to power 7 Newton. B part. After landing, the aeroplane's momentum becomes 0. Explain how the law of conservation holds here. Solution to part B. After landing, the momentum of aeroplane becomes 0 due to the retarding force. In this case, kinetic energy is converted into other forms of energy like heat due to friction and sound energy. Now second question, A part. What is meant by specific latent heat of vaporization is 2.26 million joule per kg. Answer to question 2A. Specific latent heat of vaporization is 2.26 mega joule per kg, means that 2.26 into 10 to power 6 joule energy is needed to convert 1 kg water at 100 degrees Celsius into steam at 100 degree Celsius. Now B part, a 1 kilowatt kettle contains 500 gram of boiling water. Calculate the time needed to evaporate all the water in the kettle. Solution to question 2b. Here given P is power of kettle, electric kettle, 1 kilowatt means 1000 watt. Mass of water is 500 gram means 0.5 kilogram. This is mass of water at 100 degree Celsius. We have to find time taken to evaporate all water in the kettle. Now power is equal to energy upon time. Here energy is heat, energy upon time. Heat energy needed to convert water at 100 degree Celsius into steam will be m into L of steam upon time. Therefore time will be equal to m into L of steam upon power. M is 0.5, L of steam is 2.26 into 10 to power 6 upon P is 1000. This gives required time as 1.13 into 10 to power 3 seconds. When divided by 60, it gives 18 point upon 60 gives this much minutes, which is 18.83 minutes. Third part or C part, explain why the actual time needed to evaporate water is little longer than calculated in part B. Means actual time will be slightly more than this calculated time. Why? Solution to part C. Actual time needed to evaporate all water will be slightly more than the time calculated in part B, because the efficiency of the electric kettle will be less than 1 kilowatt, because no any appliance can be 100% efficient, therefore power of kettle will be less than 1 kilowatt. Now next question number 3, part A. State any three properties of an ideal gas as assumed by the kinetic theory of gas. Answer: three properties of an ideal gas assumed by the kinetic theory of gases are: number 1, collision between gas molecules is elastic. Second, attraction or repulsion between gas molecules is negligible. Third, the volume of a gas molecule is negligible as compared to the volume of the containing vessel. Second part B. A student needed to use the ideal gas for certain experiment, but the ideal gas does not exist. Suggest what two different things this student could do to solve his problem. Answer: 3B. A gas behaves as ideal gas at very low pressure and very high temperature. Therefore, the student is suggested to perform his experiment to keep the pressure very low and temperature very high of the gas. Next question number 4. Define temperature gradient in an object. Temperature gradient is defined as the temperature gradient of an object is defined as the temperature difference per unit length of the object. Its unit is degree Celsius per meter or Kelvin per meter. B part. The question is: an electric kitchen range has total wall area of 1.4 meter square and is insulated with a layer of fiberglass of thickness 4 centimeter and thermal conductivity 0.04 watt per meter per Kelvin. Calculate the rate of heat flow through the insulation if the inside and outside temperatures are 35 degrees Celsius and 175 degrees Celsius respectively. Solution: suppose this is the electrical appliance. Inside temperature is 175 degrees Celsius, that is theta 1. it is insulated with the glass fiber. This is glass fiber or fiberglass. Outside temperature is 35 degrees Celsius, that is theta 2. Thickness L is equal to 4 centimeter, 0.04 meter, that is thickness of insulation. K is 0.04 watt per meter per Kelvin, thermal conductivity of glass fiber. We have to find rate of heat conduction. It is rate of heat conducted or conduction is dq by dt equal to K A theta 1 minus theta 2 upon L. Here theta 1 minus theta 2 upon L is the temperature gradient. So K is 0.04, A is 1.4, theta 1 minus theta 2 is 175 minus 35, L is 0.04. On simplification it gives 210 joule per second, means watts. C part. How might the rate of heat flow be affected if the fiber absorbs moisture? When the fiber absorbs moisture, its temperature will become less than, the outside temperature will become less than 35 degrees Celsius. Therefore, the difference between inside and outside temperature will be increased and rate of heat conduction will be increased. When fiber glass absorbs moisture, its temperature decreases below 35 degrees Celsius. Hence, temperature gradient increases thus the rate of heat loss will be increased. Heat loss also increases.